So in this question, we have an obtuse angle triangle. We're asked to calculate angle A, and it's not a right angle triangle, so we know we're going to have to use either sine or cosine rule. So in this case, we can use the sine rule, because in the sine rule we've got the sine rule is about relationships involving sides and angles opposite. So I've got 16, 20 degrees facing 24 centimeters and angle A facing that, so I can make up an equation involving the sine rule. So if I just write down the sine rule using in terms of A's, B's and C's. Side opposite angle A labelled with a lowercase a, side angle opposite angle B we'll call lowercase b, and the side opposite angle C we'll call lowercase c. And I'm trying to find this angle, and so the values I'm going to use A and sine A. Trying to find the angle, it's easier to write the angle information on the top. So sine of angle A over A equals sine of angle C over C. So sine of angle C is the same as writing sine of 20 degrees, and C is 16. So that's the sine rule written out in terms of numbers and angle A. So now I multiply both sides by 24, so I just get sine A equals 24 multiplied by sine 20 divided by 16, and I get 0.513030, lots of other digits. Now the thing is, if I now use my calculator and I do inverse sine of the answer to that, so I use the calculator to work out the answer, I get an angle of 30.9 degrees. But clearly that isn't the angle A, because not only does it not look like 30.9 degrees, it also mentions the question that it's an obtuse angle triangle. So this question is testing whether we're able to just think about the fact that the sine of an angle, there are many angles that have the same sine. Now, if we look at a sketch of y equals sine x, the 30.9 degrees corresponds to, say, somewhere around here. 30.9 degrees, where the sine of 30.9 degrees is about 0.513, but then the sine of the angle, the obtuse angle over here is also 0.513. Now, from symmetry between 0 and 180, we can see that this angle here is 180 minus 30.9. This distance here, 30.9, from symmetry I can see that I have to go in the same distance to the left, 30.9, to find what this actual angle is. So I do 180 minus 30.9, and I get 149.1. And that is the actual value of angle A. If you use 30.9 in your working, you will end up getting part B hopelessly wrong. So angle A is obtuse, and therefore A is 180 minus 30.9, which is 149.1. And in general, if you're using the sine rule and you know you're looking for an obtuse angle, whatever angle you get off your calculator, whatever acute angle you get off your calculator, subtract it from 180 degrees and you get the correct obtuse angle. Okay, now we've got to use our answer to help us to work out the next bit, which is the perimeter of the triangle. So the perimeter of the triangle is going to be 24 plus 16 plus whatever side B is. So we need to work out side B, and probably the easiest way to find side B is again to use the sine rule. B and the sine of angle B, and C and the sine of angle C. So I need to work out what angle B is next. Now angle B is 180 minus 20 minus angle A. So let's write that out first. So angle B is 180 degrees, subtract 20 degrees, subtract angle A, which comes to 10.9. So 10.9 degrees. Now, I can now, using the sine rule, I can say side B over the sine of 10.9 equals side C over the sine of 20. And then multiplying both sides by the sine of 10.9, this implies that B is going to be 16 over the sine of 20 multiplied by the sine of 10.9, or 16 sine 10.9 divided by sine of 20. You need to make sure that you're not, when you're typing this in, that you're not doing 16 divided by sine of 20 times sine 10.9 all on the bottom line, so to speak. When you do this, you get 8.846. So try this for yourself and make sure you're actually getting this correct. So you get 8.846 centimeters. Now that's to 3 decimal places, which is probably more than I need because the numbers here are only given to a couple of significant figures, but I'll worry about that later. So my perimeter, therefore, is going to be 24 plus 16 plus 8.846. So if I add those together, I get 48 point something, call it 48.8 to 1 decimal place. I wouldn't want to go past 3 significant figures. 2 significant figures would have been alright with full working out.